Hey guys, if you're just finding this here for the first time on the channel, check out the previous episode where we built the grinder from a complete kit, and now we'll go into building the base. Thanks for watching. All right, well, here we are. We've got the machines all assembled, motors installed. I was messing with tracking and stuff on the belt, just putting it in there temporarily. The next thing I want to do is make this tool rest for the machine. Just a simple tool rest. This is 3/16 plate. I have this piece of 1.5 inch square tube that's a little bit banged up, but it'll work just for this. I got some brackets, some tabs that I'm going to weld onto the bottom of this. I'm going to drill through this and then radius this front edge so that I can get this built, or get this on there. And then I've got a whole stand. I've got all the parts cut out for it. I'll take you over to the other side and show you that. And we'll keep on trucking on this thing. I'm really excited to get the stand built for it and figure out what comfortable height I need. This right here actually feels pretty good, I think. Matter of fact, yeah, I think right here is actually pretty good. I don't know. I kind of want to run it and see like where the sparks fly, if it throws sparks in your face, if maybe I need to make some guards or something. I don't know, we'll figure that out. But yeah, so the Torus CNC 2x72 belt grinder build continues. I'll take you over to the other side and show you all the parts I cut out, and we'll go from there. All right, so you probably already saw sort of the rough design that I drew up in Fusion 360 for this stand. And so this is a piece of square tubing I've had laying around in the shop for quite a while. This is 4-inch square tube. It's only 1/8 inch wall. So it's not quite as heavy as I'd like it. So what I plan on doing is I cut a cap for it to go on the bottom here. And before I put this cap on, I'm going to go ahead and put some scrap iron I have laying around in here just to give this base quite a bit more weight. I want it to be good and heavy down there at the bottom so it's stable. And then these are the legs. So the legs are going to go on like this on all 4 sides. And then I have these caster plates that'll weld onto the bottom. And the casters I picked up off of Amazon. I think it was like 26 bucks for 4 locking casters. And I've used them before. They're good quality casters. So I think we'll start with this, and then I'll work on that tool rest and kind of go from there. I'll make sure to put a link to all of this stuff on Amazon, including the motor and the VFD. I'll make sure to put a link to all that stuff in the description. And before I forget, if you guys need abrasives from Benchmark, you can use my coupon code for 10% off. It's TAC1FAB for 10% off at Benchmark Abrasives. You can get anything from them for fabrication, from the 2x72 belts to they sell all the different size sanding belts. They sell flapper discs, cutoff wheels, drill bits, hole saws, you name it, they got it. They even have PPE. They've got grinding masks and respirators. So if you need any of that stuff, just use my coupon code for 10% off. That's a one-time purchase, but you get 10% off your order. So it's TAC1FAB. All right, so we'll go ahead and get started on this. I'm going to drag the welder over here and start tacking these up. I need to pull a measurement off of that other table that I have the grinder set up on right now and see what kind of height we have. My plan is to go ahead and tack the legs on, get the casters installed, and then see what the finish height is on there before I cut this tube down for the height. And then for the base, for the top, I'll show you here in a bit. I had a piece of 1/2 inch plate laying around, so I went ahead and cut a base for the grinder to bolt to. So anyway, here we go. Well, the first order of business here is to go ahead and clean off the 1/2 inch top. This was a piece of 1/2 inch plate steel I had laying around in the shop. It's got a bunch of mill scale on it.
I soaked it in vinegar overnight, but it didn't quite loosen up the mill scale very much. So next we're going to clean up the column there and get out the legs and start figuring out how to lay those out. These legs are made out of 3/16 thick steel plate. I think you could have probably got away with 1/8 inch, but if you used 1/8 inch, you definitely need to bridge the legs more. The only bridging I have on these legs, other than welding them to the column, is the caster plate on the very end. With 1/8 inch, you're going to get a lot more twisting and maybe torsion on them. So if you're going to use 1/8 inch, make sure that you put some plate across the top and bottom just to kind of stiffen them up a little bit.
All right, so here we are. We got the legs welded on. I've got the mounts for the casters welded on. I was a little concerned about these legs being a little bit too spindly and not having a wide enough stance, but they're actually pretty stout, and there's a little bit of flex to them, which I think is going to be good to help this thing from teetering once I get some weight on here. This is the piece of 1/2 inch plate that I had laying around. I used the plasma table here to cut out the plate diameter and then the slots to mount the grinder on. And so what I'm going to do now is I'm going to get the casters mounted on here and start taking measurements and figuring out where I want this surface so it's a comfortable height to run the grinder. I'm pretty sure I'm going to have to trim at least 12 inches off this tube. So anyway, here we go.
Okay, next order of business is to bolt up the casters, and just like with the assembly of the grinder, I followed Rich's lead here and just put Loctite on everything. These casters come with nuts and bolts, which is nice, but they're not a locking nut.
Okay, so now with the casters installed, that thing's pretty high. So yeah, I'm definitely gonna have to cut that down. I'm gonna go look at the table that thing's mounted on and we'll see what the height. All right, so over here, this little fabrication table I have this thing set up on. The surface here is about 29 inches tall. So I think for me, that's pretty good, I think. We'll go get a piece of tubing and kind of mock what I'm doing. Yeah, I really think that's going to work. A 29 inch top surface, and then, you know, grinding and horizontally, it's just it pivots on this axis, so it's basically going to be the same height right here. Yeah, it should be about the same height. So I think that, you know, 29 inches is definitely optimal. Right here, grinding on this, I think that's going to be fine. So I'm going to go ahead and cut that thing down, and then I'll start working on getting the base mounted on there. All right, so I got her cut down, and it ends up being right at the same exact height as my little fab table that I have that I built the grinder, assembled the grinder on. So now the question is, do I want to clock the surface to where when I go to step up to the front of the grinder, I'm not kicking this leg? So in other words, do I want to rotate it to like a 45? I'm not sure. The platen on the grinder sticks off the front of the base quite a bit, like right in here. So I don't think that's gonna affect, you know, I'm not gonna be kicking this leg, hopefully. I'm not sure. I'm gonna go do some measurements and see. And I might be overthinking it, which I tend to do anyway. But I'm gonna go look and then we'll go from there. So I went and measured, and the grinder, the platen on the flat platen itself, it sticks off of these mount holes about 12.5 inches, which is gonna be almost dead even with how far this plate for the caster sticks out. So I think as long as I center the platen, the platen's gonna be centered right in here somewhere. So my feet aren't gonna run into that, I don't think. I just don't wanna be sorry that I didn't 45 this. I don't know. We'll have to see here. You know what? I think that's gonna work. I think that height is perfect for me anyway. Ends up putting the platen for the work right at 43 inches. If I leave it in this position, if I swap the arms around, it'll go higher because I have the arm in the higher position. But yeah, I think that'll work just fine. So I'm gonna go ahead and proceed. I need to make a mount for the ammo can, which is gonna go over here somewhere on this side. And then I wanna make a couple of mounts to slide the other toolbars into. And I think that'll be it for fabrication. Oh, I gotta finish up this. I gotta make the little tool rest for that, or the work rest, whatever you wanna call it. But I think that's gonna work. That's perfect as far as the height is concerned, so yeah.
So after tacking the 4 corners, I just put 1.5 inch welds on all 4 sides here. I didn't want to put too much heat into that plate.
All right, so I went ahead and put some stitch welds on that. I don't think it's gonna take a whole lot to keep it on there, and I didn't want to put a whole bunch of heat into it. So now I gotta figure out how and where I wanna mount this ammo can. It's gonna need to mount low enough to where I can still get the lid open. I don't know if I wanna mount it flat or mount it at an angle. Probably end up just taking a piece of plate and welding it to the side of this and sticking it, you know, kind of right in there. And then over here, I want to do some tubing to slide the other toolbar into. And I think that'll be pretty much it for most of the fabrication. The only other thing I need to do is mount the remote switch, that little 3D printed box I have. So I'm thinking I'm gonna mount that off of the motor. I don't know, we'll see. Here we go. Okay, so I got this plate cut out, and I designed a plate with 4 mount holes, so I just need to drill out the mount holes. I have it offset to one side so that it clears the lid when it's welded to the post for the stand. So I'm just going to go ahead and get a punch. Well, I'll mark it with my Sharpie here and see if it shows up, hopefully. There we go. Go ahead and drill these out. I'll be damned. Lined right up. Okay. We got that done. Now we just need to weld this plate to the column on the stand. Mark this. That's the front. We'll go weld it up.
After tacking this on there the first time, I realized that it was going to be too low for the extension cord on the remote control panel thing, and I'll make sure I include a link to that extension cord. It's like a communications cord. It's not Cat 5, but it's like a proprietary communication cord. What it's called is actually a lipo battery balance cord. And so anyway, I tacked it up a little bit higher. Then I discovered that it didn't matter if I could open the lid or not, because the lid slides off the side. And now I went ahead and cut some tubing and tacked those on the side.
All right, well, I think that's going to do it for that fabrication part of that. I'm going to now go ahead and add a whole bunch of weight to the bottom here, and I'm just going to find some scrap that I have and go ahead and throw in there. I think maybe I don't know, I've got all kinds of scrap over here, so a bunch of old angle iron, a bunch of other stuff I can just throw in there, and maybe put some tacks on it to tack it together, and then maybe just tack it to the sidewall, one of these here. So anyway, here we go.
So what I ended up doing here was I took a bunch of old rebar that I had laying out in the boneyard and cut it up into small lengths, and kind of tack welded each one together just kind of roughly, and then I slid it into the bottom of the column tube there, and then I put the cap on the bottom. I just wanted to give the base a little bit more weight, and hindsight being 2020, after watching this thing rock a little bit after finishing this video, if you were going to be putting a lot of pressure on the platen, like if you're building knives or whatever, you're going to want a little bit more of a solid base that's not as flexible as this, because it does move a little bit more than you probably would want. I'm not going to be putting a bunch of pressure on it, but yeah, more weight down low the better. So here, just getting the base of the machine bolted up to the top. Everything's lining up perfectly, and those holes on the base are slotted, so you can move it left to right a little bit. I think they're a 2-inch slot or 1.5-inch slot, if I remember correctly. The DXF files for this top I'll make available in the description here. I'm going to go ahead and make all these files downloadable DXF free on the Tac1 Fab website. So they'll be in the description down below. So now I just wanted to check the tilting feature. As you guys know, this grinder will tilt 90 degrees. So I wanted to make sure everything was clearing there and it was looking okay, and it sure does.
Okay, so now I've got to, here's the VFD, and the VFD is going to go in the ammo can. I've got to drill holes in the back of the ammo can for these 1/2-inch glands, they call them wire glands, to go through, and then from there I can start wiring the thing up and get the controller figured out where I want to put it. So let's go ahead and drill this. I believe the wires on the VFD come out the bottom here, so I think I'm going to end up mounting it in there this way. Turn it around this way, and I don't even think I'm going to mount it. Matter of fact, I think I'm just going to leave it in there loose, so there's plenty of air circulation. There's not a flat bottom on this ammo can. It's got this little shaped radius in the center. I think that's just to give it rigidity. So but I think that's what I'm going to do. It's not going to be bouncing around much. I might put some foam or something, but there is a heat sink on the bottom of this, so I just need to make sure there's plenty of room for that to, I guess, sort of circulate air. I mean, this is going to be sealed up, so I guess we'll see how that goes.
Just drilling out the holes for the wire glands with the step bit here.
Alright, so I got my holes drilled. And I got my wire. And I'll make sure I add links to all these parts, these individual parts that I purchased on in the description here. It's all, the majority, it's all from Amazon. So I'll make sure I add links there. I'll go ahead and run my wire through here. And I was hoping maybe I can get this controller wire in through the same spot with this other four conductor wire that goes up to the motor. So we might have to get a little creative with that, but I think we can get that through there with the other wire. Oh yeah. Okay. Well, here's the thing though. You gotta make sure that you put the gland on first, dummy. There we go. So that's all in. This, same deal. Make sure you put the gland on first. Or the gland cap, anyway. So now, give ourselves plenty of slack so we can wire up that VFD. There we go. There are diagrams on how to wire up these VFDs on the internet. There's a couple of different sources, and Rich even sent me a link to one, so I'm not going to cover that so much on here, but I'll provide a link in the description.
So on the wires here, I ended up using just these fork connectors, and I had these on hand. I've got a bunch of wiring stuff on hand, and these connectors have a heat shrink on them, so after you crimp them, you heat shrink. One thing I forgot to mention was those connectors don't fit through the little slots in the bottom of the VFD, so you have to cut a window out because they just are not big enough. I'll put a photo up here.
If you're going to use this same setup, don't do what I did and run this little extension for the control panel. Don't run it backwards like I just did. So I've got this all wired up and I've already got this run through here, and I have got the wrong end on the inside of this box. This is the male end, and I need the female end to connect to this, to the VFD. So I'm gonna have to take apart everything I just did and run this cable back out the gland and put it back right, which means I'm gonna have to cut off the end at least to one of these, probably the ground, because I doubled up the ground over here. Anyway, learn from my mistake.
So after all the wiring, it's pretty straightforward. Just go ahead and mount your ammo can to the base and wire up the wires in the VFD. I just used wire nuts on the motor connections, and then I ended up with a little 3D printed console. I ended up just drilling and tapping 2 holes in the top for that.
All right, well, we got the VFD wired up. I still got this open because I just wanted to make sure everything was working. I first plugged it in, I had a little scare, and it ended up being my extension cord end here. It's not great. Anyway, so the VFD, the controller, I'm going to mount this 3D printed little thing from Housemade. I found that he shares that on his YouTube. You can download the design for this. And anyway, so here we go. This is, I don't know if this is forward or reverse, but you can hit run. Adjust your speed. Stop. Change direction. Run. Everything's working just right. So now I just need to button all this back up and figure out how to mount this. And I was thinking about trying to figure out a little mount for all these small wheels. The work is never done, but so far I'm really happy with the way it's turning out. I still need to do the tool rest here and or the work platen, whatever you want to call it. But yeah, so I've got the other tool arm slid in there. I think that will be somewhat out of the way of all the dust, but there's kind of no way to get away from dust and sparks with these things. So anyway, yeah, good progress. I'm really happy with this. I think it's going to work great.
Well, I think here is where I'm drilling and tapping the holes in the top for the little 3D printed console box and getting that done. That was pretty simple. 1/2 inch base. If you don't necessarily need to use a 1/2 inch for your top, whatever you have laying around. All right, so the rest of this video is going to be me testing the machine and figuring out how or get the belt tracking properly and tensions. If you've made it this far, you might want to watch this for the payoff.
All right, so I've got the tool rest or platen or work rest or whatever you want to call it done. I just tack welded this. I can loosen up this bolt and tilt it however I want it. I think I've got it adjusted about where I want. I've been kind of messing around with it. I'm going to stay probably over here and we'll see what it does. This is DOM tubing that I work with a bunch, and I just want to chamfer this edge and get it weld prepped. I don't necessarily need to take a bunch of material off. This is only a 120 grit belt, so I'll see how it does. And then I've got some other belts I want to try and some other tubing I want to try. So here we go. Okay, I'm going to try the 80 grit belt, see how that does. So that does okay. I really don't know what type of belt to get for this thing. They have 3 different types. I think a ceramic, a aluminum oxide, and there's one other one, and I don't recall. I don't recall what the other one is, but here is a red Scotch-Brite belt, and I was really curious to try this. I want to see how it does with the tubing, because there's some cases when I don't need to remove material, I just need to weld prep it. And you know, I was thinking that this might be a good candidate for, you know, doing weld prep. And we're going to see how this belt runs. I'm not sure, and I don't know how tight to get it either, so looks like it's hitting this platen, so I'm going to move it a little. Still moving around a little bit, but we'll see. Normally the tubing isn't this black, doesn't have this black like mill scale on it. Usually it's very clean, a cold rolled like this. So we'll see how it does at getting this black mill scale off. Oh yeah, that's good. That's money right there. That's ready to weld. Look at that. This is really going to save my hand using an angle grinder. This other stuff that doesn't have that mill scale on it, this is normally what the tubing I get looks like. Very cool. All right, let's get the small wheel holder out and see what that's all about. All right, so we got the small wheel attachment on, and I don't know how this is going to track. I don't know how much tension to put on it. This little ratcheting tensioning system is really cool. I think I need to go inward with it a little more. Try that, see how that runs. Seems to want to run out a little bit. New here, folks, just trying to get everything figured out. So I'm going to go down, I'm going to go out with the arm a little bit. I might not have this thing set up just right, but learning. Now it's coming kind of off the tensioner. Let's see what that does. I don't know if we can use this, because it might not be long enough. Well, kind of works. Well, something just to set it on. And then we'll see how, or if, it gets in the way of doing these radiuses. So this is what the tubing looks like coming off our CNC plasma tubing cutting machine. It's called a Dragon machine. And I need to be able to get in here and grind this dross off of here and this nitrided edge, because when I go to weld it, if that's not ground and clean off of there, it'll cause porosity in the weld. So that's why I wanted to get this small wheel attachment. That is money. Well, there you have it. I am very excited to get this in with the regular tool lineup and start using it on a regular basis. It's going to save me a ton of time. It's really going to help speed up production, speed up what I'm trying to do, and it's going to save my hand. It's really going to save my hand over using a angle grinder all the time to prep these tubes. And not to mention, there's so much other versatility with these different attachments that I got, and I'm really happy that I went with the variable frequency drive and the three-phase motor, so I could adjust the speed over doing just a set speed motor. I'll make sure to put links to the design files for these legs, these caster plates. You can download them for free. I'll make sure to put the base, the design for the base in there. For the grinder itself, go to toruscnc.com and purchase yours. I'll make sure to add links to all the other parts to complete this build, including the wire, in the description. You can buy that stuff off of Amazon. You can also buy VFD drives and motors from Rich over at Torus CNC, but I decided to just save a little bit of money and buy the inexpensive stuff. He sells the higher end, I think they're called KB or KB Electronics sealed VFDs, and you wouldn't have to do the ammo can thing like I did. But anyway, and of course, if you need any abrasives, you can go to benchmarkabrasives.com and get any of your abrasives and use my coupon code TAC1FAB to get 10% off your first order. I'm just very happy with it. I couldn't be more thrilled. Like I said, I had done quite a bit of research, and I've been wanting to get one of these for the better part of a year, and I'm glad I pulled the trigger, and I couldn't be happier with it. If you guys have any questions or anything, don't hesitate to leave them down in the comments below, and I'll get back to you as fast as I can. All right? Thanks all for watching, and have a good one.